Hello there, this is Daniel, and welcome back to another SAT reading video. Today, we're going to be going through the final few questions in this passage, questions 27 to 31. Without further ado, let's begin. So, question 27. The author's use of the words exact, specific, and complement in lines 47 to 49 in the final paragraph functions mainly to confirm that nucleotide sequences are known for most molecules of DNA, counter the claim that the sequence of bases along a chain can occur in any order, support the claim that phosphate sugar backbone of the author's model is completely irregular, and emphasize how one chain of DNA may serve as a template to be copied during DNA replication. Alright, first, let's go to lines 47 to 49 and see what they say. 47 is right here. Let's start from the beginning of the sentence. If the actual order of the bases on one of the pair of chains were given, one could write down the exact order of the bases on the other one because of the specific pairing. So, we can see the words exact and specific here. And also, this you can clearly see that the words here show that like no matter what order the bases are on the other chain, you can always 100% of the time get the right answer and always get the exact right pairing of the other chain, because as mentioned earlier in the passage, each base can only pair with one other base. Thus, one chain is, as it were, the complement of the other. And in this feature, which suggests how the deoxyribonucleic acid might duplicate itself in the next lines. So if we go back down, you can see that the lines we just read suggest that a DNA chain is understood and predictable, and that if we look at the answer choices, it can't be A because the passage doesn't suggest that most nucleotide sequences are known. It doesn't say that we've already discovered like specific sequences, rather that if you know one sequence, you can predict the other. Choice B is incorrect because they're not discussing a random nature. They're not discussing how it's random. They're discussing how no matter what order the bases of the other chain are in, the other chain will always be in a specific order depending on what the first chain is. Choice C is incorrect because the author is describing the bases, not the sugar phosphate backbone. So our answer here would be D. Emphasize how one chain of DNA may serve as a template to be copied during DNA replication, because as is said back up here, thus one chain is, as it were, the complement of the other, and it's this feature which suggests how the deoxyribonucleic acid might duplicate itself. It's saying this one chain is a complement of the other, meaning both are related, and this suggests how it can duplicate itself, because each chain is the complement of the other. So, let's move on to the next question. 28. Based on the table and passage, which choice gives the correct percentages of the pairings in yeast DNA? So, let's go back up. And first we have to let's find yeast. So, yeast is right here. Now if we look at the table, we see that it was asking for pairings. Or in other words, if we go back to the passage, two of the possible bases, adenine and guanine, are pairings, and the other two are pyrimidines. The question was asking, what's the correct percentages of the pairings in yeast DNA? In other words, we are trying to find the two bases, adenine and guanine, their percentages in the table, and add them up together. So, adenine is here, and guanine is here. So if we go to yeast, you can see that means we are looking for 31.3 and 18.7%. So if we go back down, we see the correct answer has to be C, because it's the only one that lists both the guanine percentage, 18.7%, and the adenine percentage, 31.3%, because those are the two pairings. These are the two correct percentages. The other ones aren't corrected because they show different percentages, even if one of them is the same. So our answer choice for 28 is C. Now, let's go to question 29. Do the data in the table support the author's proposed pairing of bases in DNA? As we've already said before, the author's claim is that the pairing of bases in DNA, they're related. One chain is always going to be the complement to the other. If it's a guanine, it's always going to be paired with a cytosine, I believe. Yeah, guanine will always be paired with cytosine, and thymine will always be paired with adenine, meaning that the base concentrations of this and this, adenine and thymine, should be the same, and guanine and cytosine should be the same, or at the very least, very close. The table also supports this data, because if we look at every single one, adenine and guanine are both very similar, with just slight differences, and the same goes with guanine and cytosine, both being extremely close to each other. While they are slightly different, that doesn't account for much, as it could easily be slight errors or simple calculation errors in like the data, and they're close enough that it doesn't matter. So if we go back to question 29, let's look at the answer choices. A. Yes, because for each given organism, the percentage of adenine is closest to the percentage of thymine, and the percentage of guanine is closest to the percentage of cytosine. This matches the data in the table perfectly, and is also what we just said is probably as one way to prove how the table supports their thesis. But let's keep going just to see if there are any other better choices. B. Yes, because for each given organism, the percentage of adenine is closest to the percentage of guanine, and the percentage of cytosine is closest to the percentage of thymine. While this does say yes, which is what we're looking for, it gets the pairings wrong. Adenine is supposed to be pairing with thymine, and guanine is paired with cytosine, not the other way around. We can immediately disregard the other two answer choices too, because they both say no. Thus, that means our best answer is A. Let's move on to question 30. According to the table, which of the following pairs of base percentages in sea urchin DNA provides evidence in support of the answer to the previous question? So, the error answer to the previous question was that for every organism, the percentage of adenine is closest to the percentage of thymine, and that the percentage of guanine is closest to the percentage of cytosine. That means the evidence we should be looking for is something that proves that the adenine percentage is almost equal to the thymine percentage, or the guanine percentage is almost equal to the cytosine percentage. Looking at the answer choices, we really only have one choice, A, as every single other answer choice does not show how the two percentages of two bases are very similar. In fact, every single one of these answer choices shows a huge gap between the one percentage and the other. Thus, the answer we could pick is A, because these two are the closest together. But just to make sure, let's make sure that these are the actual numbers in the table. So we go back up to sea urchin. We can find yes, 17.7 and 17.3 are in fact numbers at the table. So that must mean our answer for 30 has to be A, 7.3% and 17.7%. Let's move on to the final question. Based on the table, is the percentage of adenine in each organism's DNA the same, or does it vary? And which statement made by the authors is most consistent with that data? So, this question is asking us, is the adenine percentage in every organism's DNA the same, or does it change? And which statement by the authors most consistent with that data? So, if we look back up, we can see that adenine for every single organism is different, from 26.8 to 33.2 to 24.7. As you can see, none of the adenine percentages are same, and while some of them are close, they're definitely not as close as, say, adenine and thymine. Thus, the table shows that for every unique individual organism, the adenine percentages are all different. Now, we have to find the best evidence for this fact. Now, we could search through it. Test makers are kind enough to give us the answers for us. It has to be one of these for answers, so if we just go to these lines, we should find one that supports what the claim we just made the best. So let's go to the first one, lines 6 through 8. Two of the possible bases, adenine and guanine, are pairings, and the other two, thymine and cytosine, are permittings. This does not support our claim at all that the adenine in every organism is different. So, can't be A. Next, let's go on to answer choice B. lines 25 to 26. The important point is that only certain pairs of bases will fit into the structure. This, again, does not support our claim at all, and has not related to it in any way. Next, let's go to lines 36 to 38. Adenine, for example, can occur on either chain. When it does, its partner on the other chain must always be thymine. Again, this doesn't support our claim at all. This supports the claim that each base is paired with one specific other base, but not our claim that the percentage of adenine in every organism is different. So, let's go to the final answer choice, D, lines 41 to 45. It follows that in a long molecule, many different permutations are possible, and therefore it seems likely that the precise sequence of bases is the code which carries the genetic information. This is our best answer choice, as it specifically states that there are many different permutations or combinations of different bases of adenine, guanine, cytosine, and thymine, which supports our claim that adenine for every organism is completely different. Thus, our answer choice has to be D for question 31. It varies, it follows information. Plus, the first part of the statement matches too. It varies. The adenine in each organism changes. It doesn't stay the same. Thus, our best answer choice for question 31 is D. Thank you guys for coming back and listening to me today. Listen to me again, and if you really like the video, please like it, and if you want to help support me, you can subscribe to it as well, but you don't have to. Thank you, and see you next time, where we go through the next passage. A passage adopted from 3 Guineas. Bye.